to my YouTube channel. This is Noble Hero, and we'll be talking on Pascal triangle. And how do we solve with Pascal triangle? That's the first question now. And Pascal triangle is used when you are expanding. If you want to expand an equation, let's say the equation is a plus b and has a power n. Now you use Pascal triangle if this power is a whole number. So we use Pascal triangle when the power is a whole number. And if the power is a fraction or a decimal, we'll use binomial expansion. So let's talk about Pascal triangle. How do we form Pascal triangle and how is it used? Alright, so now Pascal triangle, we start with the power of 2. With the power of 2, it has the coefficient 1, 2, 1. For example, let's say we need to expand a plus b raised to the power of 2. This would be written as a plus b multiplied to another a plus b. Alright, so if we expand this, we're going to have this with this will give us, okay, let's say a, this a will multiply this bracket here, a plus b, and then b will multiply the bracket a plus b. Alright, a times a will give us a squared, a times b will give us ab, b times a will give us ab, arranging it alphabetically, and then b times b will give us b squared. Alright, so this is what we have. And if you look at this term, this is not like terms with this. Because when we say like terms, we're talking about the variable that has the same letter in the same degree or the same power. Alright, so this is a, and the power here is 2. And then we have ab, which is different from this now. And then we have ab, and then we have b squared. Alright, so we have 2ab here. So if we want to write this again, we'll write this one down, a squared, and then we have 2ab. So we'll write it as 2ab plus b squared. Now, if you look at the coefficient now, the coefficient of this expansion, the coefficient of this expansion is that we have one of this letter a squared. We have one of the letter a squared. So the coefficient is 1, and then we have 2 of the letters ab, which is 2, and then 1 of this letter b squared. So the coefficient that we have here is 1 to 1, and that's what is written down there. Now if you expand raised to the power of 3, if you expand this equation raised to the power of 3, so if we expand a plus b to the power of 3, now this will be the same as a plus b multiplied to another a plus b multiplied to another a plus b. So this is 3a plus b, which corresponds to the power 3. Alright, so now if you expand, remember we've expanded 2 already, and what we had was a squared plus 2ab plus b squared. Now remember, this 2 gives us this, it's remaining 1, so we have another a plus b. Now if you need to expand this again, we're going to have a multiplied to the whole of this and b multiplied to the whole of this. So let's write it down. Write it down as a, this a multiplied to this bracket, which is a squared plus 2ab plus b squared, and then b multiplied to the bracket again, which is a squared plus 2ab plus b squared. Alright, so we now have this. Let's expand this now. A will multiply a squared. That makes it a to the power of 3, because this is a to the power of 2 and this a to the power of 1. So this will give us a to the power of 3. Now this with this, remember we have 2a there, which means a here have the power of 2. So let's write the letter number first. The number is 2, and then the letter a, which is in 2 places, we write it as the power of 2. Okay, and then we have b, so we put it down, b plus this with this, that will be a and b squared. Alright, so we expand this with this, and that will give us a squared b. This with this will give us 2a b squared, and then b with b squared will give us b raised to the power of 3. Now let's look at like terms here. All right, we have a raised to the power of 3, and there is no other a raised to the power of 3. So this is the only one that we have. Now we have 2 of a squared b. Now we're going to look for another of these that contains a squared and b. And this is a squared b. A squared b. All right, so this one we have 2 of it and 1 of it. So 2 plus this other one would make it 3 a squared b. All right, now the next variable should be a b squared. So we look for another a b squared on this other side. If you look at here, we have a b squared. So this is 1 of it and this is 2. So we add 1 with 2. That should give you 3 of that variable, which is a b squared. All right, so we've added up, we've written this one down, we've added this with this, we've added this with this, it's now remaining this, so we put it down, plus b raised to the power of 3. Now nothing is the same again, so now we can write down the coefficients that we have. The coefficients of this one, we have 1 of this, so we have 1 of a raised to the power of 3. We have 3 of a squared b, so the coefficient is 3, and then we have 3 of this again, and then 1 of this. So the coefficient now is 1, 3, 3, 1. So you take note of that. 1, 3, 3, 1. Now when it comes to Pascal triangle, you don't need to cram everything here. All you need to remember is this. And if you can remember this, you can form the rest of the coefficient for any power that you are looking for, as long as the power is a whole number. Alright, so how do we do that? Alright, so I'm going to write the first coefficient 1, 2, 2, 1. This is when the power is 2. Alright, now to form the next coefficients, I'm going to start with 1. Start with 1. And now I'm going to add 1 to 2. 1 plus 2, that will give me 3. Don't forget we added this with this. Now I'm going to add this with this. So 1 plus 2 gives us 3. 2 plus 1 gives us 3. And then we end it with 3. And that's the coefficient that we had there for the power of 3. So this is the coefficient that we have for the power of 3. Now from this power of 3 here, the coefficient for the power of 3, we can find the coefficient for the power of 4. So for the power of 4, write 1. 1 plus 3 gives us 4. Remember we added these 2. We added these 2. Now we're going to start with this one, with this one. Now 3 plus 3 gives us 6. Remember we are just done with this. Now we're going to move from here to this one. So this with this will give you 4, and then we end it with 1. So what do we observe? We start with 1 and we end with 1. Okay? And then we add in between. Alright, so this is for the power of 4. And you continue that way. For the power of 5, this will be 1. This will be 5. 10, 10, 5, 1. That's for the power of 5. Alright, so you can try for the power of 6 and 7, and then you drop the answers on the comment section. Okay, so you're done with this. Now the next question will be, how do you apply this? How do you apply this in solving questions? And how does this help in calculus? Alright, so we're going to start with how do we apply this first. So how do you apply this into expansion? Now we're going to expand a plus b to the power of 4. Let's expand a plus b to the power of 4. Now let's not forget that the power of 4, the coefficients would be 1, 4, 6, 4, 1. So this is going to be the coefficient that we're going to use. Now what we need to take note of is this is how it's going to progress. We're going to write down first the coefficient, and these are the coefficients. We're going to start with coefficient, first variable, which is the first letter a, and then the second letter. Alright, now what are we going to take note of now? Another thing we need to take note of is that the power of the first variable would be decreasing. It will be decreasing. So if it is decreasing, that means it's starting from the highest power. Okay? And then the coefficient of b will be increasing. And if it is increasing, that means it's going to start from 0. Alright? And let's not forget that the power of 0 will always give us 1. Alright, so let's continue. Now to expand this, we're going to start with the first coefficient, which is 1. And what we need to know about coefficient of 1 is that it is not written. Coefficient of 1 is not written in the equation. And that's the standard, okay? Alright, so I'm not going to write 1. I'm going to start with the first variable. So coefficient of 1, first variable a, and the first variable will carry the highest power, which is 4. Second variable, which is b, will carry the lowest power, which is 0. Alright? Now, in between these two, you don't add, you don't subtract. So the first step is coefficient, first variable with the highest power, second variable with 0. First variable with the highest power, second variable with 0. And then put the sign plus. Okay? So plus. Now we repeat again. Coefficient, first variable, second variable. Coefficient now is 4. So I'll put down 4. First variable a, second variable b. But what is going to be their power now? The power of a would decrease from 4 to 3, while the coefficient of b would increase from 0 to 1. Okay? Now we repeat the process again. Plus coefficient, which is the third coefficient now. Remember, this is the first coefficient 1, second coefficient 4. Now at the third point, third coefficient, which is 6. So put down 6. First variable a, second variable b. Now the power of a is going to change from 3 to 2. It has decreased. This one is going to increase from 1 to 2. Good. And then coefficient again 4. First variable, power decreases from 2 to 1. And this increases from 2 to 3. Okay? Plus the last coefficient, which is 1. I'm not going to write down 1 there. Okay? Recall, I'm not going to write down 1. So I'm going to start with first variable and then second variable. Remember this one here. This would decrease from 1 to 0. This would increase from 3 to 4. Now take note that power of 0 would decrease it to 1. Any number raised to the power of 0 is equal to 1. Alright, so the whole of this will become, this is now 1, and we are left with a raised to the power 4. So a raised to the power 4 times 1, which is still going to be a raised to the power 4. And then we write it down for a raised to the power of 3b. Now writing b like this means that the power is 1. Okay? Now plus 6, a to the power of 2, b to the power of 2, plus 4, a, b to the power of 3, plus b to the power of 4. Now this is how you expand this equation using the coefficient 1, 4, 6, 4, 1. That's how you apply the Pascal triangle. Alright, so we can try to increase the complexity of the question, but it's still going to be simple. Alright, so I don't want you to feel that since I say complexity of the question, you now feel it's going to be a complicated question. Still a simple question. So let's say we say 2a plus 3. Now we're using numbers and letters, and then the power is 3. How do you expand this? Now, first of all, before you expand this, you need to look at the power. The power is 3. And what's going to be the coefficient that correspond with the power of 3? The coefficient that correspond with the power of 3 is 1, 3, 3, 1. So this is the coefficient that we're going to use. And don't forget, we're going to write coefficient first variable times second variable. Then we continue again, coefficient first variable, second variable. All right. Now, how do you go about this? The first coefficient is 1, so I'm not going to write any number there. First variable is 2a, so I'm going to write down 2a. Now, since these 2 and a together is our first variable, then that means we are going to take it as a unit. We're going to put them together as a unit. This is one thing now, which is our first variable. These two things together forms our first variable. All right, and so it's going to carry the highest power, which is 3. Okay, while 3 is going, which is our second variable, is going to carry the lowest power, which is 0. So I could write the 3 raised to the power of 0, which we know that this is going to be 1. Before I then write the sign, which is going to be positive, we go on to the next coefficient, which is 3. So I'll write down 3, and 3 is going to be multiplied to the first variable, which is 2a, and the power would decrease from 3 to 2, and then still multiplied again to 3, which is our second variable, raised to the power of 1. Okay, now let's continue. Coefficient again 3, so I'll put it down 3. First variable 2a, and the power will decrease from 2 to 1, times second variable, which is 3, and the power increase from 1 to 2, plus coefficient of 1, so I'm not writing anything. Okay, for the coefficient of 1, you don't write anything there. So we'll just go on with the first variable 2a together, the power is now 0, multiplied by the second variable, the power is now 3. Okay, so how do we solve this? How do you work on this? Now remember, these are numbers, so your calculator would be useful. All right, so here 3 raised to the power of 0 is 1 multiplied to this, 1 multiplied to this, and now these together shares a power 3. So since we are saying that these two things together share this power of 3, that means this will be 2 raised to the power of 3 and a raised to the power of 3. And what is 2 raised to the power of 3? So we have 2 raised to the power of 3 multiplied to a raised to the power of 3. Then for this point, we have 3 here. Now I'm not going to take this 3 to multiply with 2. Why I'm not going to do that is because this 2a is under the influence of the power. So I need to first of all work on that first. So I'm going to write this 3. This is 3 raised to the power of 1, which is still 3. I can also bring it forward and multiply it to 3, and then multiply this to 2 raised to the power of 2, and then a raised to the power of 2. For our third point here, we have 3, put it down, 3 raised to the power of 2, which is 9, you can put it down as 9, multiply it to 2. Now the power here is 1, which means 2 raised to the power of 1. 2 raised to the power of 1 is still 2, and a raised to the power of 1 is a. Okay. Now for the last point, this is 0. This is 1, sorry. This is 1. So 1 multiplied by this, and 3 raised to the power of 3 is 27. So at the last point, all we have is 27 times 1. And 27 times 1 is still 27. Alright. Now finally, let's write down the values here. Here we have 2 raised to the power of 3, which is 2 times 2 times 2. And 2 times 2 times 2 is 8. So we have 8 a raised to the power of 3. For this point, we have 3 times 3, which is 9. 9 times 4. 9 times 4, 2 raised to the power of 2 is 4. So 9 times 4, which is 36. We have 36a raised to the power of 2. Okay. Now we have 3 times 9, which is 27. 27 times 2, which is 54. So we have 54a. And then the last point, we have 27. So that would be the expansion for 2a plus 3 to the power of 3. Okay, for practice, I would like to try 3a plus 2b to the power of 4, and drop your answer on the comment section. And if you're on the WhatsApp group, you can drop your answer on the WhatsApp group. And if you have any question, you can ask over there for clarification on anything that's bothering you. You can discuss it with me over there. All right, thank you for watching, and the next video we're going to talk on binomial expansion. Thank you.